This slide set the foundation for the Tuyer design. On the left, the glowing uh, section shows what happens when the blast is insufficient. That is, low raceway temperature, poor coke combustion, incomplete reduction, and poor gas utilization. On the right, the orange red section shows the opposite extreme, excessive blast causing high pressure drop, unstable body movement, and thermal overloading. At the center, the glowing equation that is required blast is equal to heat demand plus a reduction requirement plus gas flow requirements define the scientific balance we must achieve. The bottom line reminds us blast requirement is a thermofluid optimization problem. The furnace breaks through these balance. So coming to the our next slide, which is about a stepwise blast requirement calculation. And as it is shown, this slide explains the engineering workflow for blast calculation. Each vertical block represents a step. Start with a hot metal production target, then determine coke rate, calculate oxygen demand and derive theoretical air requirement. Next, adjust blast temperature and oxygen arrangement to finalize the blast volume and pressure. On the right, the Tuyer raceway visualization shows how combustion and CO generation uh, mm, interact dynamically. So the bottom note emphasizes that the modern blast design is a combination of thermal efficiency and stable permeability. So a structured data-driven process is all about. Now question arises that why blast requirement is there. So as we know that here we compare two furnaces especially. Mm, why the blast requirement rises with the capacity. This is being shown. The smaller furnace on the left has a limited reaction volume and lower gas generation. The larger modern furnace on the right has a multiple tier and a bigger combustion zone and higher gas flow. So the glowing arrow shows the sequence that higher production is equal to more coke, so more combustion, so more oxygen demand and larger blast volume. So at the bottom, the statement sum it up that increased blast capacity require higher thermal and gas dynamic input. In short, as the furnace grows its breathing system, the blast must grow with it. So coming to the two-year estimation infographic. So as you can see that this slide quantifies to your design using three key parameters. The first column shows the capacity in the hot metal ton per day. The second shows the working volume in the cubic meter, and the third shows the productivity in tons per cubic meter per day. So below the formula number of TS is already given. So accordingly, we can calculate the number of TS as per the given content. So coming to the